All right, so let's see. Y'all have any questions on any of these? No? Get them all right? 100% out of everybody. 100%. Any questions? Anybody? All right. Well, if there's no questions, get out a piece of paper. Leave your books open, but get out a piece of paper.
Yes, ma'am.
All right, you have out your piece of paper, right? This is one big piece of paper, right? So we're gonna put a 1 right here, because that's one big piece, right? Now take your piece of paper and fold it in half. Fold your piece of paper in half. Now unfold it and draw a line in the crease. Draw one line like this in the crease. Now, how many pieces is this divided into? 2. We got 1, then we got 2. All right, now fold it back along that crease. And then fold it in half again. Now unfold it and draw a line in that crease. So now, how many pieces is this divided into? 4. So now we've got 4. By the way, how many times do you think we can fold this piece of paper?
Like
5, 6, 7, 8.
Less than 7.
Yeah.
Anybody guess they can get high? Amount of folds? Anybody? What?
I guarantee you can.
We had somebody guess 12 and 16 in the previous class.
The word record is.
Did you want us to be folded paper?
Well, just fold it as we're folding it. So now you should have about this, and now fold it in half again. Fold it in half again. And now it should look like this. Unfold it. And draw a line in all the creases. Now, how many is this divided into now? 8. Now it's at 8. Hold it back up all the way. Now, fold it in half again. That should be about this size. Unfold it and put a line in all of the new creases. How many pieces is it divided into now?
16.
16. Okay. Hold it all the way back up. Then fold it again. This time it's really hard to fold, right? It's kind of hard to fold. But it's about this size now. I would crease it really good by rubbing my edge of my palm right there, or else you won't be able to see your creases. So crease it really good, and then unfold it and put a line in all of those creases. Now, how many pieces is this? 32. Are y'all starting to see a pattern yet? What's the pattern? Multiplying by what? 2. Now, if you get it back to here, see if you can fold it another time. Let's see,
Like I said,
that's 1, 2, 3, 4, 5. This will be the 6th fold, right? You gotta try really hard to fold it to be about that size. And then if I unfolded it and traced it out, how many squares would it have? 64. And will it keep going and keep going? In theory, if we could keep folding it, it would just keep going, right? But can we keep folding it? This is, she's got a nice little fold there for 7 or 8, right? That's about my 7th fold right here. It's as best as it gets. Now, what kind of function is this that we just represented? Geometric sequence, but what kind of function? What? A quadratic. Exponential. So it's an exponential function. So what's the number one question asked in math class? When are we going to use this in the real life? Did we just use this in our life?
No.
No.
When do we fold paper?
We fold paper all the time. Now, we're going to be doing some real world problems here today, but that's always the best way I like to represent exponential functions is like that. Folding a piece of paper. Did y'all know that folding a piece of paper in half and in half again was an exponential function? Close to world record, close to beating a world record. Now, we're given this word problem. As part of a project in health class, Aaliyah, Kim, and Reese are raising awareness and challenging others to eat a healthy breakfast each morning. Today, they each sent selfies of themselves eating a healthy breakfast to 4 friends and challenged them to do the same the next day. This next day, when others send out selfies of themselves eating a healthy breakfast, will be considered day 1 of their results. The following day, only those contacted the previous day will send selfies to 4 new friends, and the challenge will continue to spread. Assume everyone contacted completes the challenge and new participants are contacted each day. Whew, that's a lot, right? So we're going to skip over 1 and come back to it. Now, 2 asks us to find the relationship between time and number of participants is exponential. Verify the relationship is exponential by identifying the constant ratio. So what's our constant ratio? Let's look at our table, right? What's our table increasing by? times 4, right? Times 4, times 4, times 4. Now, why is it multiplying by 4? We look at our word problem, why? You're sending it to 4 new friends each day, which is the 4. So it's multiplying by 4 each time. Now, are there trends on Instagram and Snapchat where you get a message and it's like, send this out or tag 4 friends in this and keep the challenge going? Some of you do it, some of you don't. But this happens, doesn't it? A lot. People love posting their food. They do. Now, it says, what is the number of new participants for day 0? Explain your answer. What is day 0? Are we given a day 0?
Should be 3.
How did you get 3?
Because
Divide by 4 in our table, right?
And on the top, the thing it says 3 names.
It tells you in the word problem the 3 names, right? Aaliyah, Kim, and Reese, they started. But why is that not day 1? Haven't started yet, and it even says the 4 new friends, the results of that will be day 1, right? So we've said that the relationship is exponential because the constant ratio is 4. We know day 0 is 3. So now let's go back to number 1. Write an exponential function to represent the number of new participants of the challenge. So if we know our constant ratio and our value of 0, should be easy to write a function, shouldn't it? What is the function that we did yesterday? F of x equals a times b to the x. Not the x minus 1, just x. So how can we use this to find a new function for what's being represented today? Plug it in. What is our a? Which is what? 3. So 3 times 4 to the x. Because b is our constant ratio there. Okay. Did we just find a new function? We did. Does it work for our problem? Plug in a 1. What's 4 to the 1? 4 times 3. 12. What about 4 squared? What's 4 squared? 16 times 3. 48. So does it work? Could we keep going? We could. All right. Now turn the page to M318. Now, what I want you to do is I want you to complete the table and the graph. So on your own, complete the table and the graph. Use the story that it gives you to complete the table and the graph. It tells you in there the good information there. Read the story and plot the points in the table and graph them on the graph. That's all I want you to do, just number 1. Oh, there it goes. Just the table and the graph. Just the table and the graph. Once you're done with the table and the graph, put your pencils down so I can see who's still working, who's done. All right, y'all ready to look at this one? All right, so what is going on in this story? Just summarize it. He's got a rope, he cuts it in half, and he's got this new rope, right? And then he cuts it in half, and he's got this. And he cuts that, and he's like this, just keeps going, right? So what does he start out with? 10 foot of rope, 10 feet of rope. Then when he cuts it in half, what's that gonna be? 5. And then he cuts that in half, 2.5. And then you cut that in half. 1.25, which is also 1.25, right? I'm gonna write them in fractions. Now, what's half of that?
0.6.
What? 0.625, or in fraction, it's what? 5/8. And then what's the next one? 5/16, or what in decimal form? 0.3125. Now, could you have wrote them in fractions or decimals? You could. Now, how do we graph this? Start at 0, go to 10. 1, 5. 2, 2.5. 3, 1.25. Now 4 is 5/8. Is that bigger than a half or less than a half? Bigger than a half. It's 1/8 bigger than a half, right? So it's gonna be right above the halfway mark. And then 5/16. Less than a half, but greater than 0, right? So you're gonna be about right in there. Now, if we wanted to keep going with this, we could, right? You could just get smaller and smaller pieces of rope. All right. Now it wants us to write a function to represent the length of the rope. How are we gonna do that? We start out with our L of C, because that's what it wants us to find, right? So then, how do we create a function for this. What's our y-intercept? 10. And then what's our b? 1/2. So 10 times 1/2. And then what? To the x. Did we just create a function? We did. So now it asks us to find the length of the rope after the 7th cut. So how are we going to do that? Plug in the 7 for what? Well, this is not an x. This is actually a what? What's the variable it gives us? C. Right, so we plug in 7 for C, so L of 7 equals 10 times 1/2 to the 7th power. Okay. And then, what is this going to equal? You got a calculator, what? 10 times 1/2. Oops, that's not right. 10 times 1 divided by 2 to the 7th. 0.078,125. And then math, enter. Sweet. 5/64. Is that a lot of rope? Not at all. So 5/64 of a rope. That's a little tiny, ain't it? So another question, can you connect these lines? Why not?
Because
You're not constantly decreasing. You are going from this piece to this piece, and then this piece to this piece. You're not having any rope in the middle of different lengths, are you? You're just having those certain lengths, right? So you cannot connect these lines at all. You have to leave it in the dots. It's just a little thought. Now, will this ever reach 0?
No.
Why not?
Because it's just gonna divide it in half, it's just gonna always end up a decimal.
It's going to keep getting to a bigger and bigger decimal, right? It will never get to 0. We call that a horizontal asymptote. Horizontal asymptote. Horizontal asymptote. So what number will it never reach? 0. So we say it's a horizontal asymptote at y equals 0. Okay. Now think about it. We just said it'll never reach 0, right? How close will it get to 0? Very, very, very close. The farther you go up, the closer it gets, right? Let's plug in a 10 instead of the 7 there. 10 times 1 divided by 2 to the 10th power. Does it just keep getting closer and closer to 0 each time? It does. Let's do another one. Let's do, instead of the 10th, we'll go to the 15th. That's exponential, isn't it? That -4 means we're going to multiply it by the -4. That means we're going to have 3 zeros in front of that this time. So it just keeps getting closer and closer and closer to 0. But it's not going to touch 0, is it? It's not. So, like I said, horizontal asymptote at y equals 0. All right. So now, this is just a little bit of notes for us to take today. So this function of c, y'all did this for homework. What's it increasing by? 4. Now, is this getting bigger? Yes. So 4 is a number greater than 1, right? And then this number is a half, right? Is this increasing or decreasing? Decreasing. So in general, if B is greater than 1, what does B stand for? The constant ratio, not the y-intercept. A is the y-intercept. B is the constant ratio. So if B is greater than 1, it is exponential growth. Okay. But if B is between 0 and 1, it's going to be decreasing, right? And we call that decay. Now, if we go look at D, the graph is going down, right? What was the common ratio for that one? It's just 3, right? Why is that going down? But the constant ratio is positive, right? What's going on with that? Its y-intercept was a negative. So think about it like this. We're still calling it growth. But if you're in debt, right? And you just keep going further in debt, is your debt growing or is your debt decreasing? Your debt's growing, right? You're going in more debt. So that's why it's called growth, because your debt is growing. And then in this one, it would be a graph going like that, right? Be going up. Now we have a graph of a half right here, you know, the B is a half. So what's going on there? It's decreasing and it's getting closer to what number? 0. So decay will get closer and closer and closer to 0. Growth will get further and further away from 0. Okay. So now I want you to turn to M321. But before we do that, I've got a thought for you. If there's a frog and he starts right here at the beginning of this table, right? And he jumps halfway across. He's halfway in the table, right? And then he jumps half the distance from here to the end of the table. And then he jumps half of that distance, and half of that distance, and half of that distance, and half of that, and half of that. Will he ever fall off of the table? He can never make it to the end. Why?
Because you can never reach 0.
Can never reach 0. So he'll never fall off the table. Now, in reality, what's really going to happen? He's going to fall off the table. But in theory, he can just keep jumping and jumping and jumping and never fall off, right? That goes back to our piece of paper. In theory, we can fold this forever and it keeps going, right? But how many times can we actually fold it? 7. So just a little bit of thought for you to see it. Now, for homework, you have problems 1 and 2. A, B, and C for 1 and 2. So all of them. You can do it on here. Now, I'm going to do A with you because I'm nice like that. F of X equals. That's how we're going to start off. All these are asking is to write an exponential function to represent the population. So how are we going to find an exponential function given this table? What's this multiplying by? I don't know. How can we find it? Can we divide it? Yeah. So I'm going to go 7197 and divide it by 7098. And that is 1.013947591. So I'm going to round that to write it down. 1.03, well, 1, and I'm going to round it to 4. So 1.014. And that's our constant ratio. So it's going to be raised to a power, right? Let's see. Can you? It does, but I wouldn't do that. Don't do that. So now, how are we going to find our y-intercept? You divide it by that, right? So don't round it. Watch. Instead of having to round this number when you type it in, type in the 7,098 divided by, get second, and then the little minus button, the little negative button, it says answer above it. Hit it. All right. And that will do it for you. You don't have to round. Yes.
What's what you're saying? This is-
I'll rewrite it. It's bad. Sorry. It is 1.014 to the x. Now, did we find our our y-intercept? What is it? 7,000 something, right? We're just going to round it to 7,000. Okay. Did we just create a function up there? We did. Is that all we got to do? Yes. So your homework is 1, A, B, and C, and 2, A, B, and C. You got 6 problems. Well, really 5 problems because I did one with you.